Okay, today is Friday, August 25th. August 26th, Friday. Period 4, calculus. We're reviewing the algebra and precalculus, the review which is called the sample questions for calculus placement. Number 17, we have x to the negative 2 minus 1 all over x minus 1. Okay, so looking at this one is where I would say this is the first tough problem. I'd say it's the first one that's kind of should be somewhat challenging in the sense that, okay, I may not know what to do, but just keep it as simple in your mind. If we want something in the form a over b that only involves only positive exponents.
When it says in the form a over b, does that just mean fraction form? Like it's not really.
Yeah, they're just saying a single fraction.
Okay.
Yeah.
Oh, okay, that makes sense.
That involves only, yeah, they need to specify, and the specification is that we want only positive exponents. This is like the issue, right? Okay, well, negative 2. This guy's fine. Okay, so how could we get, what's the small, now again, to manipulate a fraction, you're only allowed to multiply the top and the bottom by the same value besides 0. What's the smallest possible value that would take care of this situation?
X to the negative 1.
If you multiplied the top and the bottom by x to the negative 1, we would have x to the negative 3 minus x to the negative 1.
Right.
Okay, so don't forget the basics. When you multiply the same base, you add the exponent.
Oh,
so
x is squared.
So x squared is correct. When I initially did this, I did x cubed because I thought, oh well, x squared would be an issue, but even then, even if we didn't have this guy here, it'd still probably be okay because x squared times x negative 2 is x to the 0, which is just 1. So this works. This is the smallest value that will work. So we do this, so you would get x to the 0 minus x squared all over, and for right now, I'm going to leave it in factored form, just in case some algebraic magic happens here and stuff simplifies, right? Factoring is usually always advantageous. It only gives you benefit, okay? So here, x to the 0 is 1, so now you have 1 minus x squared over x squared times x minus 1. If you can factor completely the top and the bottom, do that because stuff might simplify. Do you guys recognize anything that might go away? Something might happen? It should be. So this is a difference of squares. 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 I get it getting worse. A difference of squares, right? I don't know how to. It's right. You guys. It doesn't help you? Okay.
X squared and 1 squared is 1, so they
It
both
is
are
technically a difference of squares. No one said it had to be the variable first and then a constant second. No one ever said that. Right?
If that makes it x minus 1, x plus 1.
But it's negative x minus x.
Okay,
Plus
so
x times 1
it would be 1 plus x times 1 minus x.
Yeah, that's what I've been saying this whole time. I just said it's a reverse. Okay. All right.
So 1 plus x
And that doesn't really help us because on the bottom
times
is
1 minus x
1. Yeah.
all over x squared times x minus 1. Okay, so this is where it's important to be able to spot something that's the exact opposite of something. Because you can always factor out a negative 1. And that'll make something the exact opposite. It'll change all the signs. Okay, so let's say, which of these is the exact opposite of this? This is. You imagine if you changed each of these signs, you would have this.
Yeah.
So let's factor out a negative 1 so that this would change to x minus 1. The reason that I'm doing that is because it'll make it even more simple.
Why do you have to take a negative 1x?
In order for this to look just to be this, I need to factor out -1, because remember, you guys remember the rule, when you factor out -1, it just changes the sign.
X minus 1 is already, what do you mean?
No, 1 minus x
There's-
is not the same as x minus 1.
Oh,
Yeah,
that's
let's
right,
think
yeah.
about that. 1 minus x is not the same as x minus 1. I wouldn't think I'd say that, but yeah, they're not the same. Okay. But do you see it now that this is the exact opposite of this?
I was like, you cancel.
Alright. So now it looks pretty much, that's as far as we're going to be able to go. Negative x minus 1 over x squared. Yeah, this is not a good teacher doing that. I'm just being lazy because we have a lot of stuff to.
So then you wouldn't
We're not
distribute
even
1 back.
looking at that.
So
What's
you
that?
wouldn't make it x minus 1 over x squared. You wouldn't want to distribute the negative 1 back. So
You could. You could. All right. 18. You're stressing? I'll stress.
You can't just say that. Oh no, don't do that.
It's an attempt. It's an attempt. So, 18, the main principle that you need to take out of this is like convert grammatical form to exponent form. That'll help you. And then you guys know just going down the line how to simplify, right? When you have a variable over the same variable, just subtraction of the exponents.
Yeah, okay, so it's x squared and then 4x to the 3 halves. You move the x to the negative.
Let's be careful because no one's, I don't think anyone has said it correctly yet.
It's 2x to the 3.
Yes, it is. Indeed.
Oh, I see.
Oh.
Be
I
careful.
was saying
Be careful.
Okay, so that would be 1, right? So x squared.
I
No,
guess
it would be
2.
x squared. Yeah, x squared.
I'm going to move on to something else. I think 18 is pretty straightforward. You guys know the rules. There's 2 main methods, way to do 18. Some people like to move the exponents up and down to change them from a positive to negative. Other people just like to go straight down the line. Subtraction, 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 and then rewrite it properly. 19. Solving quadratics. We good.
Since you can put it in the quadratic formula.
You can all quadratic formula can solve any quadratic. That's what makes it a great formula. Yes. Can you? Maybe. Oh no.
There was a thing
I think you probably can.
I would think you can. I would hope you can. Yes, ma'am. There's the passes on the hang on the light. Are you getting this, Henry?
Yeah.
You sure? All right. Yes, 19 quadratic formula. I mean, or if you can factor, otherwise quadratic formula.
Well, one factor or a factor plus b doesn't. So you have to, and actually b becomes a like irrational solution or whatever it is.
Okay.
So it doesn't. It's
Okay.
yeah. So you do.
Quadratic formula,
B.
fantastic formula. You will not have to memorize the quadratic formula for, let's say that calculus there's a problem, but I don't want to focus on that in calculus. It's good that you know it. Number 20.
Yeah, let's yeah.
20 was complicated a little bit compared to the others.
Well,
Did
I
everyone,
didn't
did everyone get it based on the answers at the end? Did you check your work with basic solutions and everything makes sense? Or anyone you see 20?
If it's complicated, then can you do it? I didn't.
I think it's a little complicated. I'm surprised no one's saying anything. So 20.
No, I didn't work this far.
Okay. What's that?
We haven't worked this far yet.
Okay. Well, we need to. This is just to be a quick review of stuff from the past, really. So So
40 questions on it. Were we supposed to have
how
all
long
40
how long
done?
have you had this?
We were supposed to have all 40 done?
I mean, you don't I guess you don't have to do it, but I mean, if I give you something, it's
I mean, I'm asking. Like,
yeah, it's a good thing to do if I give you something to do. It's all right. So we what's that?
Usually,
Yeah, I
usually, like,
think tomorrow has to do it for homework and then you don't have to.
Okay, so we're doing it now. Is that unless do you guys want to work on it on your own and I do something else from the book, or do you want to work on this together?
This is fine, let's just keep going.
We're good with this? Okay. So for number 20, you guys remember this? Absolute value. What does absolute value mean? Distance from 0, exactly. So if whatever this is, don't even ignore how complicated it is. Think about whatever's inside of this has a distance from 0 that's less than 2. So here's 0. This guy, this whole chunk here, this 3x minus 8, can't be passed here, and it can't be past negative 2. This is the way I like to think about it in my mind because it makes it really simple. Right? If distance from 0 is less than 2. So not including these, so these would be open circles. So then now the easy way to write it is that negative 2 is less than 3x minus 8, which is less than 2.
Yeah. Just say so. Well, like what I would do is I would just solve 3x minus 8 is less than 2, and then I would solve 3x minus 8 is greater than.
It should be a negative 2 is what I. And then you put in the
values and figure out where it is. Yeah, you just do it less
And
than.
see which one works. I mean, that makes more sense. It
Is
takes
this
less
a
time.
simple way to think about it? Think
Yeah.
distance from 0?
Yeah.
I think this is the easy way to do it.
Okay.
Very logical. Okay, so you go ahead, you do this, you add 8 to both sides. So 6 is less than 3x, which is less than 10. And then divide both sides by 3. So 6/3 over 2 is less than x, which is less than 10/3.
Yeah.
It's a sad 3. All right, so we have that. Okay. No restrictions.
Yeah,
No.
Okay. Over here, kind of a similar idea of absolute value. If something squared is greater than or equal to negative 2. Sorry, greater than or equal to 2. Thank you.
yeah, so
Think about this. So x could be greater than or equal to the positive root of 2. And then what's the other statement? Because think about it, once it's squared, it's going to become positive.
plus or minus.
Less than or equal to. It's similar idea thinking wise as here in the sense that, okay, once it's squared, that value is greater than or equal to 2. And then you can always do a quick check. Okay? Root 2 would work. Negative root 2 would work. Plus anything less than negative root 2. You can plug in, make it simple, like negative 4. Yeah, negative 4 squared is definitely way greater, is greater than or equal to 2. So you know it's this. It's kind of it's a similar thinking, I think, like this. Figure out in terms of knowing it's going to be an inequality. Because it ended up being an inequality. Okay, so then it says find the solution set of the inequalities. So that one's done, and then that's done.
Because it's not between them. Like you write it
Yeah, you can't write it as, I think it's called
Yeah,
a composite or
it's
something.
not
You
between
can't really
them,
write it as
yeah,
that.
yeah.
Yeah, this is gonna look like, yeah, let's say 0, here's positive root 2, here's negative root 2.
Yeah, it's everything above and everything below. Not,
Mhm. Exactly. positive root 2 to a negative root 2?
Yeah.
The reason is because when something is squared,
Plus or minus.
it's going to cause, so it could be, so think of it as like an equation first.
Yeah.
Start from there, and then it's a matter of, okay, which greater than, less than, is it this, or is it the guys going like this?
Okay.
And you just plug in a quick test value to keep it simple.
Okay, yeah, yeah, thank you.
Mhm. Questions about 20? Okay, 21. Solving this cubic, which the only way you're gonna be able to solve a cubic is if they give you something without a calculator, graphic calculator, is if like you can end up factoring by grouping. It's gonna have to work, and this guy's probably gonna work out to something. I mean, I didn't do it, but I'm just telling you for a fact. If they don't give you something that works out in terms of for it to be nice whole integer solutions, then you have to use a graphic calculator. Unless there's some sort of fractional thing, and then you use Descartes, one of his theorems, which we're not going to go into deep algebra, which is not really going to be fundamental to calculus. But you should factoring is important. So you guys know how to factor this.
Yeah, it works out. So like when you separate it out, like it's like x squared and parentheses 3x plus 1 minus 4 and parentheses 3x plus 1.
Mhm.
So you can, since it's both 3x plus 1, you can combine that.
Okay.
And give it to
Okay, so you get these critical points, and then what you would do, what are the critical points?
critical points.
Yeah.
Like X?
X squared and
I got X is greater than or equal to plus or minus 2 and greater than or equal to
So negative 1/3 and 2 were the critical points. So we have negative 1/3.
I got plus or minus 2. And that was
2,
only for the
negative 2.
positive one. Don't you have to solve it? Oh no.
What I mean by
Oh,
critical
never mind,
points
it's not
is like, it sounds like you're telling me this.
Yeah.
Is that what you got?
yeah.
Yeah.
Okay. Here's the thing where it's like, oh, then what is it? Is it between, is it, you know, it's where it's like, what is it? Just test points in between. And then you're done. Keep something here, something here, something here, something here, you're done. It's so much easier to do it that way than try to just stare at it for 5 minutes straight, right? So you guys know, I don't know what this actual thing is. So if I plug in -3, does it make it true? If I plug in -1, does it make it true? If I plug in 0, does it make it true? And if I plug in 3, does it make it true? You either check for an X, and then you can write your actual solution in like interval notation. Good?
Yes.
Right? The main part about that, I really want you guys to get into the factoring.
Yeah.
That's more the essence of calculus than the other part. 22, just plug stuff in, yeah.
That's fine.
No problem doing,
Oh, yeah, I can plug in stuff.
composite. Okay.
23.
23. Sketch the graphs of this, this, and this. Do you have a graphic calculator?
I don't have a look.
Okay. Oh, speaking of, does anyone need a rent one? Would you like to rent one?
Yeah.
Glad I brought that up.
I don't actually want it though.
So Miss Shane came by this morning.
Can I keep it here?
What is the only one I really need an example of is C. I can't.
Anyone else?
Can I keep
That's
it
interested in
here?
possibly renting?
Yes.
You are financially liable if it gets stolen. It's $100 something out of your pocket.
Okay, again, can I keep it here?
You want, but if it gets stolen, it's not on me. You can't cry to me. You can't cry. I'm not responsible if I'm over here and someone decides to steal a calculator. I would not want you to keep it here because they're hot selling items. So are textbooks. It's not that big of a. It's a little bit larger than
You can
that.
sell those? Why would you want to buy a high school textbook? You get them for
Sorry.
Is my student ID by
It should be your N number, I would think.
N335.
I don't know either, but
I got you.
Where did I put the thing of the jig?
Today's the 26th.
Why is it TI-83 or TI-84, right?
Question Question good.
Yes.
I think that was very cool that Miss Sink got that taken care of this morning. 23, graphing a quadratic, graphing a cosine. You guys remember what cosine looks like in time from precalculus?
Yeah, I know.
If not,
I know sine, cosine.
You can punch it in a calculator and it'll come back to you. What's that?
I don't remember exactly how to graph it though.
Yeah, I think like graphing.
I don't remember how
like I
to
know
do
sine,
cosine.
cosine, tangent really well, but graphing is just.
Yeah, I can't just look at it.
Okay, you definitely need to know trick functions for calculus and just a general idea of what they look like.
Oh, yeah,
Because there may be a test that I give you or a quiz I give you which they do without a calculator, and you should know what negative cosine x looks like. Y equals negative cosine x. So
Cosine is the one that's like that, right?
Yeah, and then sine.
Yeah, the sine is that. And what's tangent?
And then it's like, is it like?
Yeah.
if you have a general idea, but then you
Oh, yeah.
get them mixed up,
Yeah.
you can always do your reference triangle. You can always do your reference triangle such that your x-axis is the one that never moves. And the thing about if you had two sticks, you could easily figure out, okay, is sine of 0, is that 1 or 0? Well, sine is opposite over hypotenuse. Okay, so imagine that this thing would be lowered all the way to 0 degrees. This stick is gone, so 0 over, say 1 if it's a unit circle. So sine of 0 is 0. This is such an easier way to know all the criticals, like 90, the 180, the 270, than it is to just memorize a table. This makes so much more sense to imagine. I don't know if anyone ever showed you this before, like that there's two sticks, like this. The x-axis is not a stick, but this and this are. And this will work every time.
And the hypotenuse.
Okay? So when you have something like, let's say, adjacent over hypotenuse. So the adjacent over the hypotenuse would be, adjacent over hypotenuse is what? Cosine. So cosine of, well, let's say cosine of 90. At that point, you now have, this guy shrinks away to nothing. You have 0 divided by 1. 0. Cosine of 0.
So then like at 90 for this.
There's technically a triangle there, but it's not really a triangle
Okay.
because like if you're doing.
You guys know SOHCAHTOA?
Yes.
Okay.
Are we graphing?
Yeah,
So
like,
this is the stick and this is the stick. This will let you figure out the 90, the 180, the 270, the weird ones that are tough for people to memorize.
He's just trying to explain the trick.
0 divided by anything except 0 is 0. But if you divide by 0, the undefined, that's where you're going to have the vertical asymptotes. Okay? The x-axis is not a stick. This is a stick and this is a stick. So imagine this is going on. So what's one that has a vertical asymptote? Not sine or cosine. They're just a wave. But tangent and cotangent. Okay? So let's say you forget how tangent starts. Okay? Well, you want to know what tangent of 0 is. Okay? So let theta go to 0. If theta goes to 0, you don't see this part of the stick. This stick would go to nothing. Tangent is opposite over adjacent. Well, what is 0 divided by what would be 1, because this guy would now be flat? What is 0 divided by 1?
0.
So tangent of 0 is 0. Okay.
Because if that angle is 0, then
Can
there's
you
no
keep having
angle.
the last bit, because this is
Like,
exactly what
okay, if you measure
happened
90
on the
to
side.
0, I'm gonna get this stick.
If you let this be a stick and let this be a stick,
The line that's the height.
and do this, you can find all the weird ones. You can find the 0, the 90, the 180, and the 270.
And make this angle 0, it would be like a.
Okay. 23, so sketching these different graphs. H of x is equal to 3 minus e to the negative 2x. You know, you can punch that in a graphing calculator, or you can just make a table of values.
Where did you say this? You're supposed to know how to,
Yeah, you're supposed to know how to
You should have a general idea of what e to the x looks like, and therefore you can manipulate it to get to there. Yeah, you should be able to grab this without grabbing a calculator. Yeah, we'll
Can we
see.
do H?
Yeah, can
Okay.
we do it?
Well, H is going to be weird because what's E squared? For example, if I want to plot points. Okay, so I won't be able to do any specific points except maybe a couple, but it'll still work out. So if I do, I gotta do this. You guys should just know have a drawn idea what it looks like. Because they'll be probably provided. So let's plot some points. When x is 0. When x is 0, what would we have? We have 3 minus e to the 0. Oh God. Undo this. So when x is 0, we have 3 minus 1, which is 2. So 0, 2. I could have thrown a graph paper, but I forgot about that. I had to hand draw this morning because the negative half decided to work. You guys know that this is an exponential function. Okay, so in general, exponential functions look a certain way. They go like this. Right? If you had the basic guy, y equals e to the x, would just look like this. Should never go, but never actually get to 0. Okay. So now you have it's e to the negative 2x and a negative in front of the e, and then a plus 3. So the plus 3 at the very end is just going to vertically translate it up 3.
Yeah,
Okay.
that's the stuff that we have to remember.
But then you have stuff where it can flip like this, or it can flip like this. I'm really not going to be too concerned about this. You will have a graphing calculator, but just know that when you manipulate exponentials, they can flip like this, they can flip like this, they can be shifted up, shifted down, left, right.
Yeah, I just don't know what thing.
Yeah, that's what we just don't remember.
Like
Okay.
in an equation. I've learned it, I just don't remember it. I never needed to remember it.
Okay, so let's say, let's go with the basics then. Like compare.
There will not be like a point where I need to graph by myself without the calculator.
I have a much easier and more efficient way of doing this, and it's a great tool to use. It's so much easier for me to just do it this way. You're like, oh, okay. It'll be nice because this is a great tool. So we have y equals 3 minus e to the power of negative 2x. Okay. So here's this. The basic guy is this. Y equals, say, e to the x. Exponential function where the base is e. So you see it's been flipped, flipped again. There's probably some sort of either horizontal compression or expansion, and then a translation. This is a great tool to review all kinds of things if you guys have forgotten what absolute value, exponential, I mean, it's fantastic, and it's great on a mobile device. It great works on an iPhone without even having to install an app. Y equals cosine x, boom, there it is. You can manipulate that. If I put a negative sign, it'll flip it like this. I don't want to spend too much time on this. It's just understanding that it's definitely an exponential function, and the manipulations that you have with any sort of function are compression, stretching, flipping, about the x-axis, and about the y-axis.
Wait, could I turn this paper into?
She should have told me. It should be on there. She may have told me. Number 24. All right, so guys, we're at the very end of class, so work on this as much as you can. It gets pretty, the last 31 through 40, you kind of fly through those pretty quickly, I think. You're mostly through the main chunk of it. So, it's fine.